Welcome to this manufacturer showcase hosted by NYSERDA's Empire Building Challenge. Its purpose is to familiarize you with new or emerging technologies meant to facilitate decarbonizing our building stock and applicable across entire portfolios. Each session will be recorded and available upon request, and slide decks sent to all attendees. Each presentation will be 20 minutes, followed by 10 minutes in which the presenter will respond to your questions. We ask that you go on mute until then. And now it is my pleasure to introduce Aurimas Sabulis of Dextall.
Thank you, Saul. Good afternoon, everybody. I'm happy to be here and happy to talk about overcladding the existing building structures and really provide some of the examples that we were a part of in terms of the projects, and also some of the developments that we're currently working on. So I'm the CEO and a founder of Dextall, and today I want to spend time talking a little bit about the product itself, like what sort of options we have for overclads for existing building structures. I'm going to dive into a couple of the projects, and I will show you what exactly we've done with them and what was the approach towards those projects. Before I go into explaining projects, I want to talk a little bit about Dextall's offered solutions for overcladding the existing building structure. So some of you know Dextall, some of you don't, but Dextall predominantly, was founded to provide unitized prefabricated solutions for new construction buildings, and so we've adapted to some degree a new construction panel for the retrofit application. So our panels are non-combustible. They're built from a light gauge steel stud system, and we have a variety of cladding material that we can use on them. That includes aluminum, ACM, which is not really allowed anymore in New York City, fiber cement, and then last one, we'll show you that we can also do some of the photovoltaic stuff as well. So this is one of the examples how the panels are being attached to existing building structure. But I also wanted to show you a quick video that I think illustrates a little bit better of what that panel installation really looks like. So you see, more of a conventional brick facade that you'll see in most of the boroughs in New York City. We then install, it looks very simple, but we essentially install brackets and the rails on the existing building structure. Those brackets obviously cannot be just attached to the brick. They are attached to more of a structure behind the brick. So whether it would be a slab condition or a block, and we do pull tests, and then we attach the rail system. The panels come fully pre-assembled, and they are palletized. There's various sort of types of how you can install the panels. You can do with the mobile crane, or you can do with the suspended platform like we're showing it here. So the panels start being installed on a starter sill, like you can see it here. The starter sill is being added at the ground floor. Panels being disassembled from the pallets. And as you can see, the panels already include cladding material. It has a window already installed inside it, and it also has a gasketing system around. So there's no caulking that is necessary when installing Dextall panels. And you can see here how the panel is being hung on the brackets that were prior pre-installed on the building. And then basically you sort of go in a corkscrew principle around the building. We do fire stopping at every level. And so the window opening matches the existing window opening. And so the old, once the panel is installed, the old window goes out. We do the fire stopping around that window, and then you basically install the, return for the drywall. So this is how, traditionally we expect the panels to go on. This particular panel is, starts at 6 inches, and you need like 4 to 4.5 inch installation gap. So it sort of extends out about 10 inches or so from the existing building facade. So there might be some encroachment considerations when dealing with buildings that are facing the existing sidewalks or public walkways. We also have introduced a new panel system called, this is a brand new development called the S-Wall, stands for slim wall. So essentially it's a mineral wool based panel that is compressed, and then it has a aluminum cassette over it. So it's not, doesn't really look like your warehouse panel. It really has the texture to it, and it's actually slimmer. So it can range the panel thickness, as you can see, range from 3 to 10 inches. It does not have a window in it. The installation methodology is very similar to what you've seen with our D-wall retrofit system. And then the window, as you can see here, stays and remains. The panel gets installed outboards of the existing facade, and then we provide the like a capping materials to cap around the window and connect the existing window with the new installed panel. This panel is actually also less expensive, and we're seeing quite a big surge of interest related to this particular product. These are a couple buildings we're doing in Bronx starting September, October, and it will utilize this S-wall panel with existing windows already being part of the structure. So we're not bringing our D-wall retrofit panel. In this particular case, we're just overcladding the opaque part of the structure. So now we have two panel systems that essentially can service slightly different requirements for the project. Like one wall, as I've showed you, has already pre-installed window. It comes as a full package deal. This just comes as a panel, but it also connects with gasketed perimeter system. Both panels have mineral wool insulation, and then we utilize, especially in New York City, either most of the time aluminum as a cladding material, but for D-wall system we have other options as well. So again, two options here. I want to talk now about some of the projects that we've done. We're currently involved. Some of you have probably seen this one or maybe not, so I'll bring you up to speed. We're working on a project in Harlem, 1660 Madison Ave. It's an old Mitchell-Lama building. You can see on the left side, this is how the building looked like. The middle image shows the rendering of what we propose the building to look like, and on the right side you see the work in progress. So we're almost done with this building, but what the process looked like, it was a little bit different than what I showed you with the first two slides, how the panels being attached. In this particular case, this project belongs to L&M. They were looking to actually open up the window openings, and once they looked into that, they realized that there's just a lot of work that has to be done around the window openings. Then potentially, overcladding or over insulating the building. It would have just required so much effort and would require so much coordination. It probably would have cost a significant amount of dollars to undergo the process. So instead, they decided to remove the existing building facade. So you can see, the suspended scaffolds, the platforms. One crew is removing the existing building facade. They're building a temporary wall, and then as soon as the temporary wall goes in, Dextall panel goes right after, and so we kind of move around the building while tenants stay in place and live inside the apartments. So that was a very challenging sort of a coordination effort on an L&M side to do that. On our case, we were the ones providing all the engineering, all the support. We don't install, but we've guided the installer how to properly install these panels. Before that, we've measured, we scanned the building multiple times. and the panels fit and they go, you know, as planned into this building structure. So we've done some meetups at the site, and we allowed a lot of folks to come in and just kind of understand and feel how the panels look like, and that how they really go into this building. So some of the benefits, obviously, you know, is the minimal tenant disturbance to some degree. You know, we just removed the existing facade while having in temporary walls, and this building is gearing towards the carbon neutrality. That's the goal. And so you can see how the new apartments look like. They also, you know, changed the heating and cooling systems. Instead of the baseboard heating, they put the PTHP units, and obviously, you know, they opened up the window openings so the tenants actually can get so significantly more daylight. So all in all, like massive improvements to tenants, and just massive improvement to how the building really looks like right now. And you can see this is the already, you know, finished one of the facade sections, one of the elevations fully finished. So now I think we're probably 20% less left on this project. The other project that I want to showcase is it's in Brooklyn. We actually, Dextall received some of the NYSERDA grant funding to create and deploy a retrofit panel, and that's how a lot of it actually has started. Dextall getting involved in retrofit initiatives is through NYSERDA, and we've developed a panel that I showed you in one of the first slides, with the window that basically overlaps the existing window, and this is a mock-up example of the project that we're actually delivering later this fall to do a demonstration case for NYSERDA, and basically, you know, enclose this entire building. So panels come in, they overlap the existing building structure. You have the window opening matches, and then the next sort of step is to remove the existing window, and then, as you saw in the video, to bridge the new window with existing window opening, so creating that little bit deeper sill. And tenants, again, this is significantly less tenant disturbance because tenants stay in place. And once the panels are installed, then you can quickly go in and then, you know, remove the existing building, the existing window, and then just wrap the window perimeter with drywall returns. So you can see here, this is that same installation. You know, it's a little bit tricky to obviously do water tests. You can't really perform the traditional water test, on-site water tests in these particular conditions, because these panels are gasketed. You know, we ran a bunch of water hose tests, and just to prove that the panels don't leak, because there's a gap between the existing building structure and our panels. It's about 4 inches, and so we want to make sure that there's no, you know, excessive penetration of moisture going into that cavity. So those are the, you know, the sort of the methods that we believe will be more commonly used than the previous one, which is essentially overcladding over the existing building structure. But just to point out, you know, there's quite a bit of work that it's required prior to hanging the panels. Hanging the panels is honestly probably the easiest part of the job. The most complicated, or I would say the most nuanced part of the job, is really measuring the building. So we do 3D scans, we collect all the point clouds, and then transfer that to Revit, where we understand the building sort of structure and all the deviations that this building has. Is existing buildings, sometimes they have bows, you know, on the facade that you really can't tell just from looking with the naked eye. The windows can be crooked to one side to the other side, so there's quite a bit of a deviation from the sort of original as-built drawings. So we need to ensure that we scan it properly, The second part is really understanding where do we place the anchors. And so the locations where we want to place the anchors, we have to do the pull tests. We work with third-party engineering companies. They do the pull tests, and then they verify like what sort of structural load can these anchor points take. So we design the anchors, then the third-party engineers approve those anchors, and that's the process that every building has to undergo, because we really don't know. Once we open the wall, sometimes it's hard to know what's sort of behind it, right? And that's a crucial part. But again, once you figure that part out, the rest is at that point pretty straightforward. Hanging anchors, putting the tracks to hang the panels, and then hanging the panels. We are also working with NYSERDA. NYSERDA provided us additional grants to create an integration, almost like a one-stop solution with mechanical systems, so heat pumps. We are probably 6 months away from launching our new product that will feature a heat pump integration within our system. So we will deliver the panel that is already, has all the ducts, it has all the perforations or louvers. So like really, we don't even need the louvers. So the metal cladding can get just perforated. And then once the panel gets to the site, all you need to do is essentially hang the box from the inside to sort of finish off this mechanical integration. So you don't need to tinker with louvers, with installation of the ducts, with installation of additional sort of returns. Everything is being done in the factory control conditions, and then all that's required is just hanging the box. We've looked at this system as more practical system to integrate mechanical systems within the prefab panels, essentially unitizing it per panel rather than centralizing it and running some sort of duct work or piping between our panels and between the existing building structure. It just requires significantly more work, and the maintenance aspect of it in this particular case could be significantly more streamlined. And then the last thing that I wanted to introduce is one of the cladding solutions that we have introduced this year is solar photovoltaic, so building integrated photovoltaic, so BIPV. On the left side, you see it's actually a new construction project, Carmen Villegas. It's a 25-story building in Harlem that we're involved in, and we're going to be supplying panels in 2025. On the right side, you can see some of the mock-ups we already made with BIPVs integrated in our panels. So again, the BIPVs essentially are replacing aluminum cladding in this particular case, and they're installed like a rain screen system. So all the inverters are installed between the solar panel and the solar cladding and our panel. And all it is once the panels are installed, the wires coming into the interior surface of the building, which needs to be sort of wired back into your grid, where you can feed into your panel, electrical panel, where you can feed that back into your grid. This can be also installed same fashion way. It can be installed in retrofit panel, and essentially, generating energy once the panels are up on the building. This particular solution qualifies for IRA tax credits. There's between 30 and 40% overall return on the panel and installation of the panel cost. So if anybody's interested, we can definitely dig deeper into it and provide a little bit more information. That's it. Saul told me 20 minutes, so I think I went a minute over. This is my contact information, and I'm happy to answer any questions that folks would have.
Thank you, Aurimas. If you could just keep the slide up on the screen, that would be great, so people can take down your information. If you have a question, please unmute to ask it, and then kindly mute again. So floor is open for anyone who has a question.
What's the maintenance like on the panels? What do you have to do for them over time?
Yeah, that's a great question. Actually, not much, because we're looking into creating a lot of modeling related to local law 11 issues, or local law 11 maintenance. You know, when we compare our panels compared to the existing building facades, which, you know, requires a facade inspection every 5 years and facade restoration. Once the inspections are done, you know, adding Dextall panels in lieu of just fixing the facade actually can prevent you, or can allow you to basically skip multiple local law 11 inspections, because they're, you know, the system is based on a rain screen, so it's aluminum cladding in most particular cases, or, you know, some of the lesser, you know, less expensive options could be fiber cement, but again, these are maintenance-free cladding materials that does not require any maintenance to it.
Anyone else? Aurimas, I had a question about the integrated mechanical systems. It looked like in the slide you showed that was optimal for new construction and new builds, but
Right.
Are you working on a version for retrofitting existing buildings with
So
just a more similar version of it?
I just didn't have the drawing, but you know, the stipulation for the grant that we received from NYSERDA is to actually create a panel with mechanical system integration that is suitable for overclad process. So yes, we are working on that, and when I mentioned 6 months, you know, we will have that solution for the existing buildings.
How do you maintain,
Great.
or how would you maintain this mechanical system that's part of your cladding? Because just the original one looks kind of like it's built into the exterior. So do you need a lift, or would you be able to get it at it from the inside the building?
Yeah, so like I'm gonna go back here. So as you can see, really what goes into our wall is the penetrations. You know, the duct penetrations. Usually, those mechanical systems will have like two pipes going outboards, one for intake, one for exhaust, and we would then the cladding part that you're seeing outboards of the sheathing board can be perforated instead of having a louver in this particular case. And so on the inside, you can see there's this box. So basically for the retrofit, the only difference is that the duct work really would span through, you know, not only through our panel, but also would span through the existing wall. So we'll have some penetration has to be made in the wall. A lot of these buildings actually have sort of a louver integrated into the wall rather than into the window. So those are kind of perfect fit projects where you can just remove the existing louver and just kind of bring the duct work through both of these panels, and then once that duct work is brought through all of these panels from the inside, from the interior of the room, you just have to hang the box.
Okay, so the box is inside, and it's just kind of how you penetrate to the outside
Correct,
for your
correct.
pressure. Okay, that makes sense. Thank you.
Yeah, and then in terms of the maintenance, right, like you can always access the box, and if something goes wrong with the box, instead of, you know, looking into centralized system and really trying to figure out where the fix is necessary, all you need to do is just replace the box, right? So it's, you know, in terms of dealing with the access to units with tenants, this is probably the easiest and most straightforward solution that there is.
Great. Any other questions? All right. Well, thank you all for attending. I guess, Aurimas, one last question since we have a few minutes. Can you speak a bit to the insulative values and air tightness values that you're targeting? I realize it probably differs for the different thicknesses of panels, but in terms of, creating high performance conditions and reaching, Ford Passive House standards, what your targets are for your system.
Yeah, that's a great question. So actually, Dextall is the only prefabricated solution provider for exterior walls as it relates to mid and high-rise applications that will have already has Passive House certification. So we went through the entire process with FIAS, and FIAS certified our panels to be used in the Passive House applications. Our value ranges in our case from 16.9 to about R30, depending on the thickness of the panel that you're attaching to the building. So again, the R16 to 30 to R30, and the air tightness is the Passive House level air tightness that ensures, the superb envelope enclosure. And really, heavily relies on a gasketed perimeter that it has multiple gaskets, and it also has vapor tapes on the inside of the panels.
Great. Well, thank you so much. Thank you also for acknowledging the support you've received from NYSERDA. I also want to mention that the first project you showed was an Empire Building Challenge project from one of our earlier cohorts with L&M. So nice to see these projects featured. And yeah, if you are interested in contacting Aurimas with any follow-up questions, you can be reached at the information shown here and in the invite. So thank you for attending, and yeah, until next time.
Thank you, Saul. Thanks, everyone.